Hey everyone, in this video I want to go over 2.1. The era of big data is here. As the name suggests, this section talks about big data and analytics. Just think about all the data captured from web applications, social media, mobile apps, sensors, and then think about all the ways in which you contribute to the growing data. Uh, I'll talk about myself. I have a smartwatch on, and that captures a lot of data. And then I have my smartphone with me wherever I go, and that's capturing data. And I'm on my computer or phone all day using the internet via various softwares. That's capturing data. When I drive, my vehicle is capturing data. When I go to the store, data is being captured. They have cameras, they have Wi Fi, there's all the transactions that I do, lots of different data. Now, big data, that's a relative term. And in our textbook, there's a section on the computer technology storage units of measure. So there's byte, kilobyte, megabyte, gigabyte, and so on. And I don't think I've ever even really ever just thought about these other sizes beyond terabyte. It's not part of my regular vocabulary, right? But we have these terms measuring the size of data. And being a relative term, big data, one way to think about that is let's go back 100 years when we didn't have computers and software doing all the work for us. Imagine having to do all of that by hand, even just 10 pages of ledger type information and doing the calculations on those. I remember, so this is kind of like not necessarily analytics, but I remember in my calculus classes that to solve one problem took me 1 or 2 pages of just writing out solving that thing. And so imagine having to do all of that hand calculations with not very much data. And so back then we would consider that big data when it was just, the equivalent of just, let's say 100 rows in Excel. In this section, it also talks about eBay, how it can predict and make suggestions on what we like or might like based on what we browse and purchase. It's fascinating how we've created algorithms to do that. And really, at the heart of it is it's just analytics from the data that we gather. I have had the opportunity to create these decision trees, which is a type of algorithm that could do something like this using Python. And it's just really fascinating to just think about how we can make these kind of predictions. So let's say you're a grocery store and you've analyzed thousands of receipts, sales data, and you found, let's say, that 90% of the time when somebody buys milk, they're also buying bread. And with that information, a grocery store could be like, since people who typically buy that would want the other, let's put bread at the front of the store, and then let's put the milk at the other part of the store. So then customers would have to walk a long distance, and there are lots of goodies in between, right? And that's what they're counting on, is that not only will you come for those two products that always come together, well, 90% of the time, let's say, well, chances are they'll run into other stuff that they might want. So when I go to Walmart and I only want to buy those two things, well, oopsie, I come out with more stuff than I had planned on. So that's an interesting way or an example of analytics at work for you. The last thing I want to talk about in this section is this cross-functional groups graphic over here. So it talks about how teams from marketing, information technology, and data science. Let's see, how exactly did the book put it? Analytics teams are increasingly interdisciplinary. So I mentioned the three disciplines on there. And functional departments no longer operate in silos. They're no longer like, we don't just have the marketing department doing its thing, information technology doing its thing, and data science. No, now they're working together, collaborating on many initiatives. All right, in the next video, we'll talk about 2.2 database management systems, or DBMSs.